Alright, in this video we will count the number of words present in a string where the words are separated by multiple spaces. Now let us first understand solving this problem through a simple example where the words are separated by a single blank space. Now in the first example we have the sentence computer is fun, where every word is separated by a single blank space. Now we can see very clearly that this particular sentence contains three words, right? And to count how many words there are in the string, we need to specify an algorithm which the computer will follow to calculate the number of words that are there in the string. It's quite easy for us to just see and tell that there are three words, but we need a concrete algorithm that can be followed by a computer, right? So one approach would be count the number of spaces that are present in a string. We already know that in a sentence, words are separated by a single space. Now, if you were to count the number of spaces, like for example, this character and this character, the number of spaces would turn out to be 2. And if you observe carefully, if you add 1 to the number of spaces that you have found out, then you will arrive at the number of words that are present in the string. Okay. Alright, so that was pretty clear to understand, right? You count the number of spaces, add 1 to it, you get the number of words that are present in the string. In fact, for any other string where the words are separated by a single blank space, you would find the following observation holds. You count the number of spaces, you add 1 to it, you get back the number of words that are present in the string. All right, but this does not hold for strings where the words are separated by more than one blank space. Okay. Now, if the words are separated by more than one blank space, then counting the number of spaces, it would not give us the number of words. For example, in this string, we have 5 spaces, right? And the number of words in this string is still 3. So 5 plus 1 does not yield 3, all right? Therefore, we cannot just simply count the number of spaces that are there in this kind of strings where the words are separated by multiple spaces. So for in these cases, we must do one thing. Now, what is that thing? Uh, the first thing would be to figure out what is the property of this space. So from properties, I mean this fact. You see, when the spaces in this particular string are always followed by a non-space character. So this space at index 8 is followed by I, which is the non-space character. Moreover, this space is followed by F, which is also a non-space character. So a string where the words are separated by a single space, all spaces are followed by non-space characters. Moreover, the character that is following the string, the character that is following the space is the start of a new word, isn't it? Therefore, now that we have identified the feature or the property of this space, I would like to ask you a question. So tell me, out of these spaces between these two words and these two spaces, let me use a different color, and these two spaces between these two words, which of the space has or follows this property? So take your time, pause this video, and try to figure out which of the spaces between 8, 9, and 10, and 13 and 14 follows the property that the spaces are followed by a non-space character. Because if we count those spaces, then this observation would hold, and therefore we will get back the number of words that are there in the string. All right, pause this video. All right. So I hope you did pause the video and you figured it out yourself. So if you chose this space and this space, the spaces at index 10 and 14, then you would be correct. These two spaces are the only spaces in this string that has a character which following it, which is not a which is a non-space character. All right. And if we count these kinds of spaces, then the total number of spaces would turn out to be 2, and adding 1 to that, we will get back the number of words that are present in the string. All right. Now, let us now that we have understood what our objective is, what kind of space we want to calculate, let us try to understand it through the help of a diagram. All right. Okay. So we have the same example here again, and we are going to traverse the entire string. Now, while traversing the entire string, we are going to extract 2 characters at a time now. We are not simply going to extract 1 character, but we are going to extract 2 characters. All right. So at the very beginning, I starts from 0 and CH and CH next are empty, and the count begins from 0, right? Now, when the value of I is 0, CH, the current character is C, and the character next to it, which is at the position I plus 1, is O. All right. Now, is CH a space? No, right? Therefore, we can move on. We don't need to consider these kinds of characters. Now, we increment the value of I by 1, and then we extract the next character. So our next character is 0, O, and the character next to O is N. That's at the position I plus 1. So O is not a space, therefore we can skip this and move ahead. We increment the value of I again, then we arrive at the character M, and the character which follows M is P. Now M is not a space, therefore we can ignore that character. Count would not be increased. Now, the length of the string is 18, mind you, therefore the valid index range for I would be from 0 to length minus 1, that's 17. Now we increment the value of I, it becomes 3. Now at the third index, we have the letter P, and the character next to it is U. Now P is not a space, therefore we ignore this, and we move. At index 4, we have the letter U, and the character following it is T. U is not space, therefore we ignore and move ahead. We increase the value of I again by 1. We get the character T, and the character following it is E. Now T is not a space, therefore we move ahead, increase the value of I. Then we get E. E is not a space, and the character following it is R, so we move ahead. Now, R is not a space, and the character following it is a space. Yet we move ahead. Now, at the 8th index, we get back a character which is a space, and the character next to it is a space. Now, the question comes, is this a space? Is the current character a space? Yes, it is. But is the character following it a non-space character? Well, no, that's not right, isn't it? Because the character, this is a space, mind you, but the character following it is not a non-space character. So we ignore this space, all right? The count still remains 0. We increment the value of I again, and we get another character which is a space, and the character following it is a space again. Now, the current character is a space, but the character following it is not a non-space character. Therefore, we ignore this space as well. This space will also not be taken into consideration. Now, we move ahead, and we increase the value of I by 1, and we get at index 10. Now, at index 10, we get back the current character as a space, and the character following it is a non-space character, and that's I, right? The current character is a space, and the character following it is a non-space character. So this is the space that we are looking for. And therefore, as we have got this kind of a space, therefore we will increment the value of count by 1. All right. Now, the total number of spaces or valid spaces that, mind you, that we have found out is 1. Now, we increment the value of I again by 1. We arrive at 11. The current character is I. The character following it is S. Current character is not a space, therefore we move ahead. The count is 1. Remained 1. Now the value of I is incremented again. The current character is now S, and the character following it is a space. Because the current character is not a space, we can move ahead. The count remains 1. Increment the value of I again by 1, we arrive at 13, and at 13 we find the character is a space, and the character following 13, which is at index 14, is a space again. So this is not the kind of space that we are looking for. We are looking for a space following which is a non-space character. So the count will not be incremented. We come at 14. Now at 14 we have the character space, and the character following it is F. So this is the kind of space that we are looking for. The current character is a space, and the character following it is not a space. Therefore, we have found our worthy space, and therefore we increase the value of count. And the value of count becomes 2 at this point. So this continues. We go at 15, the current character is F, the next character is U, count would still remain 2, next character is 16, this remains U, and the next character is N. Current is still 2. Let's duplicate this slide. All right, now let's delete all of them. Delete this. Okay. So this is a continuation. All right, so let's delete all of them. So our last value of I was 16. All right, therefore we got a next character. Now tell me, do you think that should we increase the value of I any further? What do you think? Should we increase the value of I any further? Now look, now notice one thing. I is the present index, or the index where CH is found, and CH next index is I plus 1. So if we were to increase the value of I by 1, we would arrive at 17. The current character would have been N, but the next character is missing, isn't it? And because we are always extracting 2 characters at a time, therefore when it will try to extract the second character, that is the character at the position I plus 1, for the value of I as 17, it will throw a string index out of bounds error. String index out of bounds error. Now why would it throw this error? It would throw out of bounds exception, actually, exception. Now why would it throw this exception? You see, we are always accessing the characters at positions I and I plus 1, right, to extract the current character and to extract the next character. Now, if the value of I was 17, then the value of I plus 1 would be 18, and 18 is not a valid index for this string, right? Therefore, if it tries to access an element at the position 18, then it would throw a string index out of bounds exception. And this is the reason why I should only be run from 0 to length minus 2. Why? Because we only need to run I till the second last index, because we are always extracting 2 characters at a time. Think about it. All right? Okay. So now that we have discussed the algorithm in detail, I want you guys to pause this video and try this program out by yourself. Give it a shot. I hope you will be able to do it. The only thing that we need to do is we need to extract 2 characters at a time. And because we're extracting 2 characters at a time, we must run RU from 0 to length minus 2. And then we need to check whether the current character is a space and the next character is a non-space character. Now, if this condition is true, then we should go ahead and let's say count that space. Now you see, the value of count is 2 through this algorithm, and then if we add 1 to it, then we get back the number of words that are present in the string. All right. So because this video has become way too long, I would cut this video short here, and there would be a second part to it which would have the program solution of this problem. But still, I want you guys to try this out. All right. So that's it for this video. See you in the next one, where we show the solution to this problem. All right. Bye for now.